Let's begin by importing React and its hooks, createContext, useContext, and useReducer. The createContext function is used to create a new context object, which is the foundation of the Context API. This allows us to pass state and other values throughout our component tree without having to pass props down manually at every level. Here, we call createContext to initialize a new context object, and we assign it to the variable stateContext. This is the object that our components will interact with to access the state. Moving on, we define our initial state object, which will store the starting values for the state that we want to manage across our application. Typically, this would be an object containing the initial state of various properties. Next, we set up our reducer function named stateReducer. A reducer is just a function that determines changes to an application state. It uses the current state and an action to produce a new state. Inside our reducer, we use a switch statement to handle different actions. Each case in the switch corresponds to a different action type that we expect to handle. In each case, we would include logic to update the state based on the specific action. For example, if an action to add a new item is dispatched, we would include the logic to append this item to our state in the respective case. The default case provides a safety net for any actions that aren't handled explicitly in the cases above. It throws an error so that we become aware of unhandled actions. The error thrown will help us quickly identify and fix issues in our action management, making our code more robust and easier to debug. That closes our switch statement, which forms the core of the reducer's logic. And with that, we finish up our stateReducer function. Now, we begin defining our state provider component. This component wraps around the part of our application where we need the state to be accessible. Inside the state provider, we use the useReducer hook, passing in our stateReducer function and the initial state. The useReducer hook returns the current state and a dispatch function that we'll use to send actions to our reducer. Now, let's render the state provider's children within the provider component that comes from our state context. Notice that we're passing an object to the value prop with the current state and the dispatch function. These values will be accessible to any components that subscribe to this context. Here, we place the children within the context provider. This means any child component in the component tree will have access to our state and can dispatch actions. We close off our provider component, effectively wrapping our application state around its children components, and complete the return statement for our state provider component. This marks the end of the state provider component definition. To make it easier for our components to access the state and dispatch function, we provide this custom hook called useStateValue. It calls useContext hook with our state context, simplifying the process of accessing our context values. Moving to another file, say the main entry file of our Next.js app, we import the state provider and use stateValue hook from our previously created context. Here, we define the MyApp component, which wraps around every page in our Next.js app. We proceed with the return where we'll wrap the page component with our state provider. By wrapping our component with the state provider, we ensure that every page has access to our global state and dispatch function. Here, we render the current page component passing all received page props, ensuring that our pages receive their necessary props as usual. We close off the state provider, and with that, our app now has a persisted state across all components. And finalize our MyApp component's return statement. Our MyApp component is complete, which means our app is now wrapped with the state provider. Don't forget to export MyApp as the default export of the file so Next.js can use it as the custom app component. Now, let's see how we would use our state and dispatch function within a component, say some component. We start by calling our useStateValue hook. This gives us access to our state and dispatch function directly within our component. We can now use the state to display data in our component or dispatch actions to update the state based on user interactions. Finally, we render our component's JSX while potentially using the state to drive what gets displayed. This wraps up the SomeComponent function component, showcasing a practical use of our context within the component tree.